Evening all. So we will discuss two different type of concept in machine learning. One is basically called the problem of classification, and another one is the problem of regression in machine learning. So let's first discuss on classification. So as you can see that classifications and regression both belong to supervised type of learning, as we have discussed earlier, that there are basically supervised learning, unsupervised learning. These are the two major categories basically we use in machine learning. And apart from that, there is another category which is known as reinforcement learning. We'll be having a discussion in a later stage. So first, if you have a look on the classification, so basically it's dealing with the values which are generally categorical or the discrete values, like say, for example, any specific type of labels or class. While if we consider about any specific type of regression problem, which generally deals with the continuous value. So that's the fundamental difference between classification and regression. Let me repeat. So classification generally deals with the categorical value or the discrete values, and regression generally deals with the continuous values, isn't it? Like any specific type of number. So basically, once we're talking about classification, any specific example also, if you can consider, so will give you an idea where we start making a category. Okay, so if you have a specific set, and from that particular set, we start making a category, like say, for example, an email can be of a spam, or it can be not a spam. Okay, so this is obviously one specific type of category. And as I already told you, it generally deals with any specific discrete level. So if you consider any specific use case, for example, it can be credit card fraud detection, it can be a cancer diagnosis, or it can be a specific type of image classification, isn't it? At the same point of time, let's have a look on what are the algorithms which we will be learning in a later stage regarding the classification. Like say, for example, logistics regression, a very common algorithm which is used for any specific type of binary classifications task. Followed by that, whenever we are making use of an hyperplane, okay, and basically in a specific dimensional space, we make use of SVM, which is known as support vector machines. Any specific type of decision-based input, whenever you're using, we make use of the data structure called tree. And based on that, the algorithm is known as the decision tree. At the same point of time, any specific type of ensemble of decision can be represented with the help of random forest. And lastly, we have an algorithm called K nearest neighbor, or KNN, which is completely based on the data point, isn't it? And there we also explore the possibility of having a nearest neighbors. So these are certain algorithms which you will be learning in a later stage, coming under the category called classification. If you see the example which I quoted earlier, like one is basically the email spam classification, where we start classifying the email based on predefined keywords, or it can be a sender address. And here also, the most important thing we need to understand that what exactly is the accuracy of the model in predicting that whether an email is a spam or not. At the same point of time, we can also do using image classification. Suppose we have different animals like cat, dog, or different objects, different models of car which we would like to classify. We can make use of the image classification strategy. So this is also another example which is coming under classification. Now, coming to the main part of regression, here generally we deal with the continuous value, isn't it? The outcome is explicitly numerical, and generally we can say any specific type of prediction whenever you're doing, say, for example, prediction of stock, or prediction of the price of a house. So these are all common examples of regression. Let's have a look on the common algorithms which generally we used in regression. Say, for example, linear regression, which is one of the most common algorithm, which generally explore a relationship between the independent and dependent variables and exploring certain type of graphical line over here. So we will understand that in a later stage. At the same point of time, instead of linear regression, it can be used for an nth degree polynomial. That's basically known as a polynomial regression. Similarly, whenever you are taking an extension of SVM, which we have studied in classification, similarly, we have an algorithm called support vector regression, which will be discussed in the next video. That's basically performing any kind of regression task. And another one, the last one, basically, which is based on decision trees and random forest, that can also be used for regression, which we discussed earlier for classifications too. So these are certain common algorithm, as you can see, for the regression. Now, if you see the examples which you have quoted earlier, like I start figuring out the price of any house. For real estate industry, this is obviously one of the very important data, and your model should be capable of predicting the price of that house. Obviously, it is a kind of numeric value. So that is one example of regression. Followed by that, we can say the forecasting of weather, forecasting of humidity, wind speed, isn't it? And suppose I would like to predict the temperature of a next day, or I would like to predict whether it's going to rain tomorrow. So these are certain type of prediction where the output is a continuous variable. So that's basically what exactly we call it as the regression, isn't it? So in summary, if you like to see the difference between classification and regression, so you can see that generally classification deals with the discrete values, regression generally deals with the continuous value. At the same point of time, there is a specific goal for classification related problem, as we have seen earlier, that generally it's for a particular class or level where if we consider regression, it's basically a continuous outcome based on your input. Now, this third one is very interesting. We will be having this analysis on this evaluation matrix. There are different evaluation matrix. Explicitly, we can say model evaluation strategies, which is actually different in classification. As you can see, accuracy, precision, F1 score, AUC, these are all used for the classification to find out the performance of a model. The same, if we consider for regression, it can be MSC, MAE, different type of scoring process generally we use for regression. Examples we have already quoted earlier, like segregation of emails can be a classification problem, whereas predicting of the house price can be one type of regression problem. And we also had a round of discussion on the nature of the algorithms basically used for classification as well as for the regression. The most interesting part, which we'll be doing using Python Jupyter Notebook, is various types of applications like credit card fraud detection, medical diagnosis, maybe object detection, recognition in the field of classification, and at the same point of time, stock prediction or any specific type of time series forecasting can be the examples for the regression. Let's talk about evaluation metrics in a nutshell, so that whenever we will be using Python Jupyter Notebook, so you will get a clear idea about what are the metrics basically used for the classification problem. As you can see, accuracy, precision, recall, F1 score, AUC. So these are all different type of technical strategy basically used whenever we start figuring out how correct the prediction is. That's the most important thing in machine learning. Okay, so we will be having a round of discussion in a later stage regarding the evaluation matrix. Now, just have a look on the name of the classification matrix. Let's get familiar with the name to understand that what exactly the way a model get evaluated for a classification. Similarly, if we consider regression, we make use of mean square error, we make use of mean absolute error, R square. So this is a certain process which is basically used to figure out the difference between the predicted and the actual value. So these are certain evaluation metrics basically used for the regression. So that's all about our today's discussion. I hope you understood the basic difference between the classification and the regression problem. Thank you.